acceleration is defined as a change in velocity over time. So when we look at acceleration, it is a change in velocity. Now remember, velocity is speed and direction. So it's the change in speed and direction over time. By formula, acceleration, that is a vector quantity. It is a change in, so we're going to use our delta V over time. Now the delta means change in. And of course, if it's delta V, that is a change in velocity. We can have a delta, you're going to see in this year in physics, that delta is going to be used in front of many symbols. So it's a change in. So that just simply means it's final velocity minus initial velocity. So delta means final minus initial. So my acceleration is final velocity minus initial velocity over time, and that's the full. We write it this way most of the time. So what does that look like in a sample problem? Well, let's do one. A car starts from rest, so that's going to be my initial velocity. Starts from rest, that's 0, and accelerates to 20 meters per second. So my final velocity is 20. And this happens in 15 seconds, so my time is 15 seconds. What is the rate of acceleration? So that's what I'm trying to find, is my acceleration. So my formula is delta V over time. So my acceleration is equal to 20, which is my final, minus my initial, which is 0, over time, which is 15. So my acceleration is 1.33 meters per second squared. My unit for acceleration, let's go back up here. My unit for acceleration is meters per second squared, because the velocity is changing. That my velocity is changing every second. So I have to account for that in the formula. So this is going to be my answer for this problem. It's a great idea that when you work physics problems, put what's given over here down the left side, and that gives you all the room over here underneath the problem to work the body of the math. It's a good idea to begin with, is to put the formula that you're using. After a period of time you don't need that anymore, but for right now you might want to continue to do that. The givens over here tell me what formula to use, because they tell me what I have. I have an initial velocity, I have a final velocity, I have time. It tells me what I'm trying to find, which is acceleration. What formula fits these givens? Well, obviously it's this one. So this is the problem this is the formula that I'm going to use for this problem. So next we have finding displacement with velocity. So now I'm going to find displacement, and I'm going to use this formula to do that with. So notice I have final velocity squared, initial velocity squared, I have acceleration, and now I have displacement. So what's missing? Notice that there's no time. So we're going to solve this one without time, because I have a change in my displacement. So what does that look like? Our object starts from rest, so that's an initial velocity of 0. And it accelerates a distance of 50 meters, so that's my displacement. Oops, just 50 meters. And it's at a rate of 2.4 meters per second squared. So my acceleration is 2.4 meters per second squared. So what is the final velocity? So that's what I'm trying to find. So my formula is final velocity squared is equal to initial velocity squared plus 2 times my acceleration times my delta x. So my final velocity squared, my initial is 0, plus 2 times my acceleration is 2.4, and my displacement is 50. So my BF squared is equal to 240. So take the square root of both of those. I've got to get rid of the square. So my final velocity is equal to 15.5 meters per second. One of the most common mistakes I have with students is them forgetting to do the square root. We've got to get rid of that square. So notice we solved this problem without the function of time. So our next formula is finding displacement with time. So notice I have my displacement, my initial velocity, and I have my my acceleration times time. So what's missing in this one? Notice there is no final velocity. So we're going to do this one without a final velocity. The car has an initial velocity of 10, so I have an initial velocity of 10 meters per second. And it accelerates for 10 seconds, so there's my time, at a rate of 1.2 meters per second squared. So that's my acceleration. Pay attention to the units. They will tell you what the unit is. They will tell you what the value is. So how far did it travel? So I'm going to try to find my delta x. So my delta x is equal to initial velocity times time plus 1/2 acceleration times time squared. So my initial velocity is 10 and my time is 10 plus 1/2. My acceleration is 1.2 and my time is 10 squared. So now it's just doing the math. This is 100 plus 60, 160 meters. So this car traveled 160 meters in 10 seconds. Why? Because it's accelerating at 1.2 meters per second squared. So don't forget, you have different formulas based on what's given. This one, no final velocity. This one, I have no time. And then of course this one is my base formula that I will use for acceleration. My suggestion to you is to go back and work these problems again. Try to maybe cover up what's happening here, work it without looking at it, and see if you can get the correct answer again. Repetition's a good thing when we're working with physics problems.